Friday. For those of you joining, what are you doing this weekend? Throw it up in the chat what you're looking forward to doing this weekend. Where are you in the world? If you don't yet know what you're doing, I guess a lot of us are at home. What book are you reading? What's the TV show you've been enjoying? My guilty pleasure lately is I've been watching Cobra Kai, the Netflix sort of sequel to Karate Kid. It's a little bleak. It's a little bleak, I'm not gonna lie, but it's scratching that 80s itch from my childhood. I want to share with you all, friends, too. You can probably tell this is a virtual background, but this is actually the room I'm sitting in. I'm here sitting in this chair, which is against a blank wall. So it's an incredibly dull Zoom background when I'm sitting in it. And I was actually thinking, maybe I should move my furniture around so I have a better Zoom background. And I was like, actually, this is the lazy way. So this is my Zoom background. I'm sitting in this chair in this room. I should probably get a picture of me actually sitting in the chair, which is be especially sort of strange or unusual. The strange world of Zoom backgrounds. For those of you just joining, feel free to share where you are in the chat, where you're coming from in the chat, and what your plans are for this weekend. I'm realizing now that I'm missing playing some music. I could hum for you. I could sing for you. Should I sing for you? It's not unusual to be loved by anyone. Yeah, I'm sorry. I'm sorry. I didn't plan that, and that probably shows. Sorry, everyone. But we do need like a little elevator music, a little muzak. Should have brought my own. This is Asheville, North Carolina. Thanks for asking. This is I moved here a few months ago from beautiful New York City. Moved here to the mountains of North Carolina. It's a lovely, progressive little city. All right, we can sort of get started here. Well, friends, I'm Josh. My name is Josh Clark. I run a design agency called Big Medium, and I help companies and you, I hope, design for what's next. I'm going to talk today about what it means to work with machine learning and artificial intelligence in your everyday products and everyday practice. What is machine learning for? How do we get it? And then how do we use it, or how don't we use it in some cases? So I'll be talking about our opportunities with machine learning and AI, but also our responsibilities, and maybe some new ways to think about what we've learned about machine learning and what I would say sort of its awkward adolescence over the last few years. I'm going to share a lot of information with you in the next 90 minutes, so we're not going to be doing any hands-on exercises during the session, but I'm going to give you some homework, some things that you can take back with you to do on your own or with your colleagues. And of course, I'll be pausing along the way to answer questions. I think by now most of you have it, but down at the bottom of the window here, you'll find a Q&A button where you can ask questions and of course use chat to share your ideas and reactions and resources with one another. But before getting to all of that, I want to start with a summer day in this pasture in Colorado. I think you'll agree this is not a likely place for a traffic jam, but on this one day, a single car rolled down this narrow dirt road that cut across this field, and then another followed, and another. And before long, dozens of cars were bumping along this barely maintained road, which is still swampy from a whole weekend of rain. And a few cars bogged down in this deep mud, trapping the cars behind them. And within just a few minutes, nearly 100 drivers were stuck in the mud in the middle of nowhere. So what was going on here? Well, local station KMGH has the story, friends, from an eyewitness named Connie.
Why did Google send us out there to begin with? It just didn't make any sense. There was no turning back once you were there.
Why did Google send us out there? It turned out Google Maps was responsible for the pileup. All 100 drivers had dutifully followed the service's directions when it offered a detour around an accident on a nearby highway. The detour was supposed to save 20 minutes, and so with blind faith, this whole herd of cars plunged into the mud. Now, there's a twist to this story, too.
Connie, by the way, is related to our traffic expert, Jason Luber.
No, I look, my wife gets stuck in traffic jams too.
He says this reliance on technology to get around town can cause headaches.
It's a failure of people not knowing how to read a map, people relying and blindly following their technology.
You know, he's got a point to some degree, but also, do you know what I call that? I call it blaming the victim. All too often, we blame the user for being too gullible, or even blame ourselves for being too addicted or too trusting of our phones. As users, of course, we do have responsibility, and we should have a certain data literacy about how and when to use these services. But I think this is also showing a lapse on the part of the designers of these services too. And that's more than just a technical lapse. Obviously, there was flawed data behind the Google Maps mudfest. The service seemed unaware that its chosen route was barely a road, and a private road at that. So as mature and reliable as Google Maps certainly is, it still sometimes fails us, right? That's a technical observation, though, and maybe the least interesting part of it, because I think there are some interesting questions for designers here. What does it mean that AI products aren't just interpreting the world, but shaping it? And services like Google Maps or Waze don't just give traffic advice, they effectively determine the traffic, right? Because every driver uses it, it shapes how the traffic is around the world at any given moment. How do we design for that outcome? Do we even want that outcome? How can AI products do a better job at handling the imperfect and frankly weird recommendations that machine learning often delivers? How can we predict that or anticipate that? How might the product itself set expectations and channel behavior in a way that really truly matches the system's ability? And how do we promote trust in that? How might AI services engage critical thought or amplify human judgment instead of replacing it so that we just blindly follow its recommendations? Friends, these are design challenges. These are questions about what these products are for, how we should deliver their recommendations, and how we should recover from their mistakes. We're going to be talking about some of those really nitty-gritty design patterns. You know, when do we want to use machine learning? How do we use it? What are again, the design patterns that we want to use? But there are also these sort of broader challenges that I'll be talking about today as well, which is, you know, how do we use technology in a way that it wants to be used, that's mindful of its limits as well as its strengths? And how do we do it in a way that adds meaning, that doesn't just add noise to people's lives? And really sort of amplifies human potential, which sounds sort of fancy, but really what I'm talking about is engages human judgment in ways that let us do the things that we're best at and lets us sort of sidestep the things that we maybe aren't that good at. I find these questions to be especially important when we turn into new chapters of technology. And I think this is one of those times. We're working in digital design at an incredibly exciting moment, also a fraught moment with the arrival of a new design material called machine learning. As I mentioned, I run a design agency called Big Medium. We specialize in designing for what's next. And for the last decade, I would say, you know, a big focus of that was on mobile devices. You know, how do we sort of take advantage of all of the new features and capabilities of these devices, adapt to a range of screens and so forth. But in the last couple of years, I've really sort of seen our work shifting more and more into machine learning and AI. And if mobile defined the last decade of digital design, machine learning is already defining the next, is what I'm finding. And I think a lot of designers don't yet understand our role in this, but I think there's an urgent role to play, and that's what I want to discuss today. So machine learning is a design material, just like HTML and CSS are design materials, or like great writing is a design material, or like dense data is a design material. And like any design material, it's important to understand its texture, not only how it can be used, but how it wants to be used. What are its strengths and its weaknesses that inform how you should present that content, data, information, or interaction? So what does it mean to use a new design material? Well, I think it's really about, understanding what it can do for you, where you can get it, what are the materials that are available. And so in this case, where do you get machine learning if your organization doesn't have that competency? What is its grain? And by that, that's what I'm talking again about its texture. So just like you work wood and it wants to be worked in a certain way with the grain, every technology has a way that it wants to be worked too, and that inform, again, its strengths and weaknesses. And finally, how does it change us? What does it require of us? What do we pay in return for using it? So that's what we're going to be talking about here today, if that sounds good to you guys. Let's charge ahead and start with kind of that first question of, so what can it do for us? Or put another way, why team up with machine learning? What's the opportunity there? Well, broadly, the promise of machine learning is essentially, if you could detect patterns in anything, how might we act on them? Machine learning already drives so many of the digital products all of us use every day, of course, for better and for worse, like we saw with our friends out in Colorado. Algorithms determine, the way we drive, but also the news that we see, the movies that we watch, the products that are surfaced. And this is all the pattern matching power of machine learning surfacing generally useful insights. What does this mean for you in your everyday practice, though? There are sort of 5 broad categories of applications that I want to run through just to sort of kind of start to shape and categorize how machine learning might fit into your sort of products, right? And some of these are going to be very familiar. So I'm just going to go through them quickly. Let's look to Slack for an example of recommendation. Slack has a feature for big teams that helps you find people who talk about certain topics. So this is machine learning that helps you find experts in your organization. So here, if you need an expert in hiring process, Isabella is your go-to. And this is recommendation, right? It's a ranked list of documents that match a specific context or concept. Super familiar, right? This is search results, really. In this case, right, it's more than just doing something that is sort of brute force keyword matching. This is, sort of matching a concept. So this is helpful in sort of saying, if there's a concept of hiring process, Isabella here is someone who talks about it a lot in this channel. So anyway, recommendation, a ranked list of documents that match a specific context or concept. This is closely related both to classification, which I'll discuss in a bit, but also to prediction. So let's take a look at that. Predictive keyboards, another example of just everyday machine learning. The statistically most likely next word or phrase showing up above the keyboard. So you just tap it to plug it in and then continue, right? A simple intervention, just a small intervention to speed this error-prone task of touchscreen typing. And that's prediction, right? Based on historical data, here are the things that are most likely to happen next. Let's look at classification. Google Forms, which is likely familiar to many of you, Google's survey building tool. When you add your questions, you choose the format of the answer that you want. And the default is multiple choice, so radio buttons like you see here. But there are a lot of options here, and they've made it as simple as they could, but it still takes some time and thought. But look what happens when you start typing the question text and how that changes the answer format. How satisfied are you maps to a linear scale. So they added a little machine learning to the mix to look at your question and classify it to a specific answer type. Which of the following apply maps to checkboxes, right? So just a convenient bit of intelligence to make the process easier. So classification is human-generated categories, the answer types here, where the machines map content or data into those categories. And you think about it for Google, they've got billions probably of question examples that human beings have mapped to these answer types. So they just said, hey, machines, look at all these examples and do that pattern matching yourself. Now, one thing that I'll look at this, as you look at this, is look how mundane some of these examples are, right? So when we're talking about AI or machine learning, it's not, the sentient robot butler that we were all promised. The point here is that machine learning can be part of your everyday toolkit and make appearances in our everyday UI. We can drop in machine learning as casually as you'd add JavaScript to a web page. We use JavaScript to sprinkle interaction into a page. We can use machine learning to sprinkle intelligence, little nudges to help along the way. You know, as I mentioned, machine learning is sort of already defining this coming decade of digital design. And so we need to get as comfortable designing for the algorithm as we've become designing for the small screen, or as we're using JavaScript in a web page. It's an enhancement that's becoming part of the everyday for a select few companies for now, and for everyone very shortly. It doesn't have to be a big deal. Your product doesn't have to be a big fancy artificial intelligence something something to use this stuff. It's not magic. It's not beyond the means of your company or of you. And so I'm going to describe some services later that you can use right now to get into this. But my point right now is that in many cases, machine learning is actually best deployed for small interventions that solve critical tasks in any given activity. But there are bigger opportunities too, where the machines can discover new insights. And that's where we get into sort of this next application that I wanted to mention, which is clustering. This can feel either like magic or nonsense, frankly, depending on the success of the algorithm. So this is completely unsupervised by human beings. The machines just go out and find patterns. So clustering says, these things are different from the average in these common ways. That's a cluster. Here's another group that's different from average in other ways. That's another cluster. So it's like classification, but it's done by machine logic, not human logic. All right. So the opportunity here is that it helps us to identify invisible patterns. It can see things that we wouldn't, both because of the scale it can use, but also because machines can find patterns that we're not tuned to. So it's a way to identify ways in which things depart from the normal or the average. It can be things like fraud or crime or disease or spending outside the norm. But groups of data points that sit outside that sort of baseline notion of normal in some interesting way. That also means you can use it to identify clusters of products or customers or people by behaviors or associations that might not be immediately apparent or obvious. So just one very sort of simple and familiar example of this is sort of the spelling or query suggestions that Google makes. It's basically here sort of saying, there are clustered associations, semantic associations between words that, foul odor is unusual. That's not normal, but it's adjacent to something that is normal, foul odor. So it's taking these clustering things to sort of say, these typically do not go together. Let's find something that is much more often, right? So TED Talk instead of Ed Talk. I'll show you an example that combines unsupervised clustering and that sort of semantic association, again, with content generation. And you begin to get glimmers of what looks like creativity. Douglas Summers Stay is a researcher who's interested in artificial creativity. And he created a wordplay generator where you give the system a word or an idea, like rocking chair, and it comes up with a 2-word rhyming description, like knitter sitter, right? Or Star Wars gets you droid overjoyed. Tons of these things. So it's a system that's based on semantic vectors, like we just saw in that Google example, words that sort of go together. It organizes words that have strong associations. So here it finds those words and then runs them through a separate algorithm to find the pairs that rhyme. Just a fun example. We'll look at some more powerful clustering examples later. But as we sort of look at what is possible for generation, which is really what we're talking about, is the machines creating, making, writing, drawing, making pictures, building something themselves. Over the last few years, an AI lab has been developing a language model called GPT, And last summer, they released their latest version, their third version, appropriately called GPT-3. It's an incredibly sophisticated and complex model that's trained on just a huge amount of text. So it promises to take on any language task. And basically, the idea is that with very little training, you can give it some seed text and show it a few examples of what you want it to do. And it can kind of get up and running on its own. So a couple of examples. Here you can tell the model whose knowledge and voice you want to tap. So today we want to learn from billionaire narcissists, I guess. So we give it Elon Musk along with a question. This isn't scripted. This isn't scraping Wikipedia. This is the model generating text. It gets a little bit more mind-bendy too when you realize that text and language doesn't have to be conversational like you're seeing here, right? It's when you're talking about it generating text, we often think about chatbots, which is sort of like this thing responding on the fly based on sort of some seed information. But what if we want to do computer languages? So here's another example using the GPT-3 model to understand English language and generate, in this case, React code to build a little web app on the fly. So it says, I want to have this mood tracker and give me a button. And when I press the button, say that it, say how I'm feeling. So it's great. It's recognized the question, it's processing it. And you'll see it only takes really a few seconds, but it understands the request. And now here on the left, you can see it's actually generated the React code. So again, it's just like this system that is, with a few examples, starts to understand language and text in all kinds of different contexts. And I don't know, why don't we actually sort of, it also, because of this breadth of training, also understands emoji associations with words, right? So kind of crazy, but it's like this is also sort of something and a service that you can use to build on top of to sort of generate text responses to things. Again, this is the thing that can feel a little bit like nonsense or magic, depending on how well it's trained. And I think that we're sort of starting to get a little bit further out there in terms of what some AI interactions would look like. But broadly, these are the 5 categories of machine learning smarts. And ways to kind of think about or categorize how AI or machine learning can help you. Let's look at what happens when we start to bring these kinds of things into the realm that we work in every day. You probably recall Quick Draw, a Google experiment to identify sketches. It sort of came out a few years ago, sort of one of the first sort of really broad and somewhat whimsical machine learning applications that Google put out there. The whole sort of idea of it is that it challenges you to draw. So we'll give it a try, challenge you to draw a mountain. Oh, I know, it's a mountain. Do it with a calculator. All right, I see a square, triangle, elbow, dishwasher. Oh, it's a calculator. Pretty good. All right, draw a hamburger. And it's guessing a shoe, a hot dog, a hot tub, bread. It's a hamburger. Didn't even get to put my condiments on there. I got it so fast. All right, let's do one more. It's a flip-flop. I see a potato, a peanut. It's flip-flops. If you're not familiar, flip-flops, sort of like the beach sandals, right? This does not look anything like a flip-flop. This is a terrible drawing that I did here. Let's look at, one of the things you can see is it tells you first, what your drawing kind of resembled. And, it's not wrong. It also looks like a potato or like bread. My drawing of flip-flops is not exactly very compelling. When you look at what other people drew, though, you start to see what's happening here is that really a flip-flop, we're really drawing symbols for flip-flops here, right? It's an oval with a little arrow or chevron in it as much as anything. And when you're really realizing, it's like, oh, the system is not necessarily at this point understanding these super realistic images. It is recognizing the symbols that we draw for them. And of course, we draw symbols all the time in our work. We're often going to sort of start with loose sketches on paper like this. And so we're starting to see a wave of services that are aimed at capturing these as well. So here's an example in that case of generation and classification. There's a web app called Wizard. I think it's Wizard, UIZARD, like GUI, only Wizard, you decide. UIZARD.io. And what it's done, and I'm going to show you sort of a little bit of an older version of the software. They just this week came out with a new web-based design software package that incorporates this feature. But basically what it does is it invites you to take a picture of a sketch. And here I just had a very simple kind of inbox sketch that took a picture of. And then I'll take you over to its web interface. And you can see here on the left, that's the picture that I took. And on the right, it's the interface that it generated from that picture. Yeah, it's doing pretty good, right? It's got some, let me grab the sketch file of this while I talk through it. It's got a couple, it added for some reason 2 search bars at the top, but it generated this sketch file. So let's see what it is. And you can see inside, this is, it's an actual sort of sketch thing with editable text. It's got this thumbnail image here that I can drag around or resize, and it understands that these are rows, so it's put all these elements in a group. And if I click into one of these elements, I can see in Sketch, oh, it's a symbol. And you can sort of start to understand that what it's done is started to understand these symbols that we've drawn and mapped them to design elements, right? So this is all somewhat fairly simple, right? And of course, in this case, it may not be that these are your patterns or your design style or your code conventions. But there are in this thing sort of style guides where you can edit colors and typefaces and border radiuses and everything. But what if the system was tuned specifically to your brand or your site or your code style? Really what we're doing then is we're sort of mapping these sketches to this vocabulary of design patterns. And when we do that for humans, we call that a design system. Design systems establish standard patterns and a common vocabulary. And if you've established that, you can share that language with the machines too. Add it to the symbols and notation you already use. And then, so speaking of vocabulary, maybe you don't even need the sketch in the first place, right? Just say it out loud. Hey, Alexa, give me a page with these elements, and boom, you've got a rough working prototype. It's not going to be ready to ship, but you've got something roughed out to start to work with. And some of you might be saying, hey, wait a second, that sounds like my job, but it's not. That's the clerical part of your job. That's transcription, kind of dutifully translating a sketch to a comp to markup, using components that have already been designed that we don't have to sort of do work to create, which is again is what a design system is for. That's not where the real thinking happens, especially if how to do it is already solved. The whole idea of a design system is a repository of solved problems. Only now we can share those solved problems with the machines so we can solve new ones. Sorry, Morten, I see that I triggered your Alexa there. This is one of the other things, right, that we'll be talking about in a bit, which is the weirdness and unreliability in some cases of the machines, or the ways that they can misunderstand their environment. And that's one example of me triggering Morten's Alexa. But to come back to this example of what the machines are good at, it turns out, if we think of this as sort of taking over some of the maybe clerical rote part of our production work, if you think about the kinds of things that people find painful, again, sort of these sort of clerical sort of responsibilities, or just the things that we sort of find ourselves slogging through, things that tend to be time consuming, repetitive, detail oriented, error prone, or joyless. We hate stuff like this. It turns out the machines are great at them. Let's let the machines do these things so we can focus on what we do best. Here's one example. We did some work with a healthcare company, and they were zeroing in on ways to help radiologists do their jobs better, the people who examine x-rays and scans looking for problems, right? In reality, their work looks more like this. So much of their time is looking at scan after scan after scan, looking for the same telltale signs. Most of the work is looking at scans without problems, nothing there at all. So only occasionally do they find a problem, something in the scan that engages their actual skill to determine what that mass is, what kind it is, what it means for the patient. So what we were able to do is get computer vision to do a huge amount of triage so that the radiologist could apply their actual expertise. So it wasn't the machines diagnosing the problem. It was the machines bringing the radiologists the interesting cases. They took over the time-consuming, repetitive, detail-oriented, error-prone, joyless bit so that they could really engage their focus. Very successful. So what we want to do, in other words, is use machine learning to let people do what they do best by letting the machines do what they do best. And they are almost never the same thing. How can we amplify our humanity, engage human judgment by supporting our activities in ways that are uniquely possible through machine learning? I see, by the way, a note around this, around an observation about the X-rays, about sort of false negatives, and this is exactly right. Is you want to sort of really adjust the sensitivity here so that you don't get false negatives where nobody is looking at the thing. So something that we took really seriously is just really making sure that we wanted to tilt things so that the radiologists were seeing more rather than less. So we were able to sort of get a lot of negative results out there, but we also wanted to avoid false negatives. Super important point. So the idea here, though, again, is that we're able to focus attention and judgment. The effort should not be to replace human judgment, which I think is very much that point about the false negatives, but to focus it. Let the machines sort of set the table for our real work, our real thinking, do the hard work that we're bad at, and set us up to make the informed decisions that we're good at. So focus attention, engage our judgment, show the radiologists where to focus their expertise, clear away that noise, and help signal where we can do our most interesting and creative work. Today, you'll see that AI is a poor substitute for human judgment, but it is an excellent signal booster for human judgment and individual agency. Our industry has spent a lot of effort to make the machines smarter, and so I think let's instead put a premium on how we might augment human capability, start with that human need, and understand how machines can help. One of the things I just want to come back to a question that Andreas asked, which is in the classification example for Google Forms. How do you know that the example is supervised by humans and not unsupervised? You may not always be able to tell that from the user side. So there's a little bit of a question here or I'm sorry, how do I know is perhaps the question. The supervised aspect of it is that those classifications already existed. So when it's supervised versus unsupervised, what you'll see is that in the unsupervised clustering example, it's kind of the machines grouping things randomly and just being like, these are like or unlike in different ways. Whereas categorization is a training where humans are saying, hey, these are the different kinds of categories that we're interested in matching, and then it's really specific training. So it could also be, for example, if you're dealing with images, say a system where you want to categorize leaves, you would really sort of say, this is an image of an oak, this is an image of a maple, this is an image of a larch. And so you're really sort of saying, here are these categories, and you are training the system to put those into those categories. Clustering, by contrast, is just sort of saying, hey, robots, here's a whole bunch of data. You group them in whatever way makes sense without any kinds of sort of names or categories. I hope that makes sense. Feel free to let me know if there's a follow-up. All this is to say, right, to sort of come back to that original premise, is is that we're really sort of trying to figure out how we can detect patterns and how might we act on them. So I talked about that in terms of those 5 applications, but there's also sort of 4 categories of problems that you can think of. So I want to give that to you also as another way of thinking about how to bring machine learning into your products. One is it helps us to be smarter with questions that we already ask. So, one of the things, for example, I think that Slack example is a really good one, is that we're already sort of doing kind of searching, but instead of doing keyword searching, we're looking for concepts. So we're using classification or clustering to understand conceptual relationships between documents or people or trends. So instead of doing a keyword search for, human resources, I can actually find things that are about the concept of human resources. So we're able to sort of just do things that we're already already doing, but do them better, being smarter with questions we already ask. It gets interesting though when we're able to ask entirely new kinds of questions. So again, sort of going to this idea of querying content and sort of through search engines, keywords, or concepts. Instead of keywords, we can also ask questions based on emotion, for example. So a customer care representative could queue up emails that have anger or urgency or concern, right? Or I don't know, maybe it's just the start of the day and I want happy, kind emails. But it lets us ask an entirely new kind of question, right? It's just sort of like we can ask a question in a domain that we hadn't been able to search for before. Another example is to unlock new sources of data. So all the messy ways that we communicate as humans, speech and handwriting and video and photos, those used to be totally opaque to the machines. But now they can understand and find meaning in those data sources. So how might we tap those as data sources or for interaction, in computer vision and speech UI, for example? So in other words, it's not just a source of data, but a platform of interaction in a lot of cases, right? Which is, I think, what we're seeing with a lot of sort of a new wave of interfaces that are camera-based, for example, speech-based. And finally, and this comes back to this clustering idea, is surfacing the invisible patterns, letting the machines categorize and group and cluster data to find new insights. So this is, really sort of what I'm getting at is like kind of 4 kinds of categories of problems and ways to think about what machine learning can do, mapped against those kind of 5 applications. And really, this is the work, right? Is figuring out what problems to solve. That is our work of UX. And in the realm of AI and machine learning, where can we point it at problems that are worth solving and that machine learning is uniquely good at? So what I want to do is sort of introduce your first kind of homework assignment that I'm going to give to you, and which is really a framework, an outcome-based framework for helping to identify AI opportunities in your products. It's these 4 steps. I'll walk you through them now, but I encourage you to give this a try next week, either on your own or with your colleagues. And so let's go through these first steps. First, what outcomes do we want? I love that this has been such an important thread through all of the sessions over the last few days, kind of having clarity about the meaningful outcome that we're trying to achieve. There's been something that I think Jeff talked about with OKRs, Kate, of course, with identifying and measuring your metrics, Jared, in terms of defining UX strategy. I love here how Josh Seiden, who's often been a collaborator with Jeff actually in several books, I love how he frames outcomes, that a change in behavior that drives business results. There are 2 things I love about focusing on changes in behavior. First, you can design to it. Interaction design is all about shaping behavior, right? It makes it a concrete thing that you can design for. And second, you can measure behaviors. You know if you're being successful or not if you define your outcome as a behavior, because that's something that you can like literally go out and see, have we actually moved or changed that behavior? So just as a simple example, let's say that we're working on that Google Forms survey product we saw earlier. The outcomes we want to see might be something like, editors publishing more surveys. That means people starting, creating, and finally sharing surveys. Again, it's a meaningful behavior change and one that we can measure, people pushing that publish button. We might want to see more respondents finishing surveys. And we want to reduce support calls. People need less help. And so the behavior change we see is a drop in sending those emails or making those phone calls and so on. We just keep going. What are the behavior changes we want that will drive business value? And then we want to ask, what's preventing these outcomes? What are the frictions that people encounter that block or slow these behaviors? So when you do this on your own or with your team, spread your outcomes out, on Post-its on a wall or on a Miro board, and then list those frictions one by one under each outcome, and then just, collect them like so. So much friction, you guys, so many problems. These are the problems we can start to solve. So let's see what that looks like, again, in the context of one of these outcomes that we had. Let's look at some of the frictions that might be blocking editors from publishing more surveys. First, maybe it's too hard. It takes too much time to make the survey or even just to use the interface to set up the questions. Or maybe editors don't have clear goals. It's hard to make a good survey if you're not clear about your outcomes. Or maybe you aren't bothering to create a survey because you don't have easy access to a large enough audience and you're not sure how to proceed. Obviously, these things should be informed by UX research. And so we sort of are understanding really close up what are some of the problems that people are encountering, again, the blockers to those outcomes. So from there, we can start making some hypotheses. And I call this stage, turn that frown upside down, because we're often just inverting the friction to state our design hypothesis. So if it takes too much effort and time to create a survey, then editors would publish more surveys if we make it faster to create a survey, and a good survey at that. That's our hypothesis. Or we believe editors would publish more surveys if we can help editors clarify their goals. Or we believe editors would publish more surveys if we enable access to a big relevant audience. So you throw them all up on the wall, and by the end, you've got a bunch of hypotheses of what you need to do to get your outcome. As you can tell, it's not specific to AI or machine learning here. At this point, we've got a great strategic setup for what we should be doing for our UX, so hypotheses for how we can achieve meaningful and strategic outcomes. So now we look for where AI can help, right? So if before we've kind of got an interesting framework for just sort of like, here's the problems that we're setting up that we ought to be trying to solve and some hypotheses of how to drive outcomes. Now we want to sort of slot into this specific elements where AI can do the work. And we look back at what we were talking about earlier today, and it's things that are, about detecting those patterns and acting on them with those four categories of problems. But also, what are the tasks that the machines are good at and people are not? Again, that list of time-consuming, repetitive, detail-oriented, error-prone, and joyless tasks. What are the things where we tend to make mistakes more often than the machines do? And then we can think about those applications, those 5 categories that we talked about, and perhaps even map them to the sort of specific superpowers that we sort of see as being both data sources as well as sort of points of interaction. And that maps, just a sort of a point, those new data sources that we were talking about and those 4 kinds of problems or questions that we can act on. That maps to what those superpowers are. So as we sort of like kind of go through that, again, I want to sort of remind this doesn't have to be super fancy. It's sort of like, what is one intervention that we can make, these small interventions, little nudges or help that can take the edge off of those time-consuming, joyless tasks that we were talking about. So this is kind of the cheat sheet, and this is included in the slides, friends, that'll be posted just, I believe, minutes after we're done here. Got a PDF of your kind of homework assignments, this exercise that you can run. But once you put these things up, we've got our hypotheses here, and we sort of map and sort of like, let's identify what those tasks might be to sort of bring to test that hypothesis. So just, in this case, if we want to make it faster to create a good survey, one thing that we could do is just sort of flag, is this a biased or leading question? And that's sort of something that with a little bit of training for some good questions and bad questions, you could at least sort of start the machines to be sort of like, hey, take a look at this. This may not be a well-worded question. Or perhaps, as we already saw that Google Forms did implement, is to suggest the best answer type for a question based on the millions of examples that they've already got there. There may be some opportunities to sort of make the survey wording tighter, that the machine learning can look at similar questions and suggest a different structure, since really kind of concise, pointed wording is important in surveys. Other ideas, speech recognition for input, maybe to speed the input of this, show the estimated time that it will take a respondent to complete the survey so far, so you have some idea of how you're doing in terms of authoring this thing. So anyway, these are just like some quick examples. Some of your ideas will be great, some will be ridiculous, some will be too hard. The idea is to capture them and have some discussion with your team. Which ones are most likely to help prove out our hypothesis? Which ones fit best into the mission and manner of our product? Which ones are we well positioned with data or with our tech capability? I do this with a lot of companies, and we recently helped a company introduce some AI features into its call center software for its customer support agents. And so the big outcome they wanted to see is to help their agents reduce call times. So we followed that process that we just went through here to create this brief. And we did indeed take some of these features to build into the interface for customer service reps. So we show the outcome we want, the high level business impact that the outcome will have, in this case, reduce costs, and the frictions, hypotheses, features to get that outcome. And this helps us tell a story to the whole business. We're not just building cool features. We have a considered strategy to drive to an outcome in ways that only machine learning can deliver. So your homework is to make a similar brief. How do AI features drive specific outcomes in your product? Where does it fit? And that's, sort of brings to a close the first chapter of this class, how to figure out where machine learning fits into your product, what it can do for you. I see Amanda asked the questions about what are some other concerns you've come across when using machine learning in healthcare, and how did you handle it? And I'll say a couple of things. One is this sort of false positive, false negative thing. You want to be super careful. The goal here broadly and in general is not to replace human judgment, but to sort of replace the stuff where human judgment is often kind of weak, and where we can use it to focus attention. So it's sort of something about sort of putting flags on problems rather than trying to get people out of the thing entirely. I'll talk about some examples later in terms of ways to frame this around healthcare as ways that can actually, instead of making it a colder experience, making healthcare more compassionate by sort of taking some of the things, again, that people aren't great at, and helping them focus on the stuff that they really are, which in a lot of cases is compassion and human contact. So one of the things that we've really seen in general in healthcare, in all industries, is that there's often an attempt with automation to remove people from the process, remove human contact. And one of the things that we've really been trying to do with healthcare is actually automating some things with the goal of actually making the healthcare more human, more humane, more contact where we need it, instead of what we see in the United States is often barely any contact with a doctor, really short visits rushed through. How can we create more spaciousness by automating other parts of the process? All right. Now, great, we've identified, sort of like where you might fit machine learning into your product, but where do you get it? What if this is not something that you have a lot of data scientists and algorithm engineers running around your company? Where do you get all this machine learning? You might think, and I think a lot of people do, that this is sort of only for the tech giants. It's actually more readily available than you might think. Google, Microsoft, Amazon, IBM, at the same time that they're all hustling for new breakthroughs in machine learning and artificial intelligence, they're also kind of competing to give it away. And they all offer intelligence as a service, intelligence as a utility, practically for free. Machine learning services are becoming a commodity, just like server hosting. And in fact, often given away for free as part of a hosting package. So here's just one example from Microsoft. If you have even a free Microsoft Azure web hosting account, you get access to Microsoft's cognitive services. That's their fancy name for kind of machine learning services. Amazon, Google, IBM, they all have similar offerings, basically free to experiment and prototyping with things. Microsoft's a great place to play because they have a lot of services ready to roll and easy to use. So if you scroll down here, you can see all the different services that are available to you, all the machine learning superpowers, right? You get services around data analysis, what they call decision here, as well as language understanding, speech, vision. So here in decision, you can find outliers in your data, how things depart from normal in some interesting way. What we were talking about is sort of the clustering example. They have specific services for that around content moderation, looking for bad behavior, and also a personalizer to match content to behavior. a recommendation prediction engine, basically. If you move down to language, you have services like language understanding to translate natural language into instructions that a service like a chatbot or Alexa could understand. Text analytics down below lets you understand the topics in a set of text, as well as the emotional sentiment in the document. Is this an angry, happy, sad piece of text? If you move down to speech, you can see all kinds of speech recognition: text to speech to text, speech translation, where you can speak text in one language and it translates that text in real time to another. And then vision, where you can use the computer vision services to identify objects in a photo, or down below, there's even like a form recognizer that lets you extract meaningful data from paper forms. And yes, a face API, where among other things, you can identify the emotion of people in photos. So let's take a look at that. Their emotion service identifies faces and reads their emotion. So here we're looking at how the robots understand the expression of the guy on the left. And they've categorized him by the 8 stages of emotion that we've all felt about Microsoft at some point, I'm sure: anger, contempt, disgust, etc. Generally, though, he's happy, with some neutral, some subtle notes of disgust and sadness, which I think, describes stock photography in a nutshell. So well done, Microsoft Emotion API. But look how easy it is to use. The idea is that you just feed the service an image, and you get this highly structured data back in JSON form. So this is sort of like kind of basic to intermediate web developer stuff that you can really connect to these services and get meaningful data back to work with in a familiar format for a web developer. Microsoft has tons of services like this that you can use and sort of start prototyping, start getting things in. And of course, if your prototype proves out and it actually moves toward that outcome that you're looking to design for, then you can look at actually sort of bringing it into maybe more of a paid service or building your own. Same with Google Cloud Platform, right? Site or computer vision services, language translation and understanding, conversational or chatbot services, lots more. Same from Amazon, right? Where we've also got sort of like all the services under the hood that they use to build Alexa, basically, with sort of chatbots and understanding. And then they've also got sort of their speech recognition. You can make your service use Alexa's voice if you like. So one thing, though, that I'll encourage, and these things are, again, very accessible from both a developer point of view and also as a way to sort of browse and experiment from a UX point of view, which I'll talk about in a moment. These things are not all the same. This is not one size fits all. What's the data that fits your needs? And you'll find that even in these services, there's a little bit of some differences in the way that they see and understand the world. So it's worth sort of, I know this goes a little bit beyond the realm of what is typically sort of part of UX, but it's important to sort of work with designers and developers to understand, is this the model and data set that actually fits our audience's needs? So there's a real partnership here between UX and development. So you might have specific images that you're working with that have very explicit challenges to discern differences. For example, can our computer vision algorithms manage this impossible situation? And friends, I want to give you a little trigger warning. This next image is a little bit challenging for a few different reasons. Yeah, I really do apologize for this one. I know we have to submit to these sacrifices, though. Image recognition is hard work. It turns out that this one, though, is a kind of canonical image in the AI world, kind of a meme for AI data scientists, sort of a shorthand for talking about the challenges that machines face in interpreting the world. My friends at TopBots actually went through and saw how a lot of the kind of publicly available image recognition services did with this. They went to Amazon's Rekognition and Microsoft and IBM and Google and CloudSight and Clarify. And if you look into this, there's a lot of food recognition here. Microsoft often thought it was a stuffed animal, right? So if you actually look at Microsoft here identifying this, it's like, oh, this is a brown and white teddy bear, or this one is a close-up of a stuffed animal. And what that's actually telling you is that Microsoft's kind of image data is probably built around a lot of sort of home, family images, a little weak on food. But that's sort of an example, sort of doing that kind of analysis on the kinds of things that you are working with is important. I will also sort of say, though, as you're thinking about, well, how does my organization sort of build on top of these things, is that a lot of these services also let you customize them. So, for example, I mentioned, doing something to categorize like leaf images, for example. Say that's a service that you're trying to provide. If you take pictures of a leaf and you post it to any of these services, it will not identify what type of leaf it is. It will only tell you that it is a leaf. But you can sort of start to build on these and train. So Google Cloud has something called Cloud Auto ML that basically lets you supply just a relatively small amount of examples and train it for, in this example, types of leaves. You could probably do it with 100 or 200 images compared to the millions that it might take to train a new model from scratch. And you'll start to get results. Amazon has a very similar service with its custom vision to sort of be able to build on top of their sophisticated image recognition to train it on specific images. From a text point of view, I already mentioned the GPT-3 language model, super sophisticated model where you can sprinkle a little bit of your own data into it to take advantage of its smarts in a very tailored way. The last thing that you can do is also sort of build your own model, and sort of it's pretty related to some of those custom examples. Here there's a service that's called Lobe that builds machine learning models for you. You drag and drop the training data, images, sounds, photos, text, and then kind of go through online and say what each photo represents. You train it. So you export then your trained model to Core ML for iOS or TensorFlow for Android, sort of all the tech stuff underneath. So it's a model that then is run in an existing machine learning framework. So that means that designers can create the basic model without deep know-how. So you can also learn to do this stuff closer to the code. But there are a lot of frameworks out there for building and training models in Python, for example. But all to point out is that you don't have to be a data scientist or a machine learning expert to start to get the benefits from this stuff. So you can do all these things today. Use a public API, test for your data, customize the model, build your own. And so I encourage you to sort of think about that as you think about where would machine learning fit into my product. Know that the services are there and available to use without a huge kind of barrier to entry. I see there's a question from Franz asking, why do these companies provide these services, kind of for free? Especially since nothing is really for free, right? And I will sort of point out that you're absolutely right. A lot of this stuff is like to train sort of in a specific domain of sort of general image recognition, for example. They want to have more examples to kind of continue training their model. So it's getting put to use primarily just to sort of, continue to train and improve the data model. And you can look to their terms of use, of course, to sort of see if anything else is happening with the data. That's the primary thing, though, is that they're sort of like trying to get as much data as possible to improve their model. One of the things that I'll mention here then, right, is that particularly if you are dealing with really sort of privileged data or information, you may not want to use these services for actual production. So I think that one way that it feels like a real no-brainer to me, an obvious thing to do, is that these are great places to prove out prototypes and sort of see if it's worth the investment of doing more, of building your own model and with your own data. But you're right to sort of have some caution or skepticism of, so what are they doing with this? Where does this data go? You may not want to build a business on top of one of these things, given all of the kind of common issues or problems about building any business on someone else's platform. A couple other questions that I'll take real quick before moving along. And one question from Hendrik is, how do we avoid baking our human biases into the rules we design while training AI? And it's a great question. Hold on to that thought. I'm going to get to that in a little bit as we look at sort of some of the texture, the strengths and weaknesses of AI and how to avoid them. And Diana asks, how is machine learning handled in B2B where data anonymity is crucial and where clients don't want to share their data, even though it may bring them other benefits? So you're going to need the data to sort of form the model. And so obviously you sort of need to make sure that you're using data that you have permission to use. And I encourage transparency always with customers about how you're using data. There are, though, a growing number of things that both Google and Apple are experimenting with, for example, of having essentially lightweight models that can sit on the device, particularly on the phone, right? So that for things like image recognition, where privacy is more and more of an issue, and there are things that maybe people don't want to send to Google, there's sort of stuff that now can actually be analyzed and done on the device without actually sort of adding additional data. So there's a mix of things here, right? Is that as you're training the model, you're going to need access to data, and often a lot of data, especially if you're doing it yourself. But you want to have really carefully considered policies about where some of that data can simply sort of sit locally on the device and not actually be shared or reside elsewhere. A really important question. Thanks for asking that. And the last thing is, how do you test your model and data and ensure that it will work the way that you intend to? How much testing is required? Hang on to that too, because I'm going to talk about that as another issue where it can be really hard to understand what these models are thinking and ways to work around that. But the short answer is that it's really important with machine learning to kind of constantly be checking in on how it's doing. One, to make sure that it's not doing something you don't expect, but also that the benefit of machine learning is kind of constantly reinforcing what it's learned and refining its model. That closed loop of results and feedback and retraining is an important part on the data science side, but also on the UX side. Just measuring that we actually are driving the outcomes that we want and expect is important. And that relates also to Hendrik's question earlier about bias, which we'll touch on in a moment. Hendrik, I see you asked about no code or low code tools. Sorry, I'm not actually totally sure about that. That's getting a little bit closer to the metal than I usually get. I suspect that all of the services I mentioned offer a variety of different tools and frameworks for getting at their services. So that might be a place to look. So some homework then that I want to give you is actually get in there and try it, to work with it. A lot of times as UX folks, we don't work very closely with the data. We think that's sort of like the developer's problem or with the services directly. But one of the things that I mentioned that's great about Microsoft's cognitive services is that they have a web interface to all these different services that are really sort of easy to use. And I encourage you to get in there and try these in particular. And look at the data that comes back to understand the nuances that you can expect from them. We'll look at those data formats in a minute and why that's important. But as you look at it, really sort of see what it's good at. Try to trip up these services, give it challenging images or text examples and see how it does with them. What is it bad at? And when you look at the data, and we'll look at this in a bit later to see what I mean, does it know when it's wrong? You know, how do you trust its level of confidence in what it's saying? Is it sort of being like, I think it's this, or I know it's this when it's wrong? Do you trust it, and for what? So I encourage you to actually spend some time playing with these things. It's sort of fun and often hilarious what these things are good and bad at. So that's a piece of homework for you. All right. So this is where we're going to spend most of the rest of our time together here in the next half hour, is thinking about what is the grain of this technology? What are the unique qualities of machine learning and AI as a design material that give us cues about how we should work with it? What are its strengths and weaknesses? And when I think about the grain of machine learning, there's a lot of aspects to it, but today I want to share 5 particular aspects or eccentricities. Starting with the fact, friends, the machines are weird, right? They study the world, they sift through enormous volumes of evidence and data, and they come to what are often sometimes surprising, and in some cases alarming conclusions, right? I think some of the concerns some of you have raised around healthcare is sort of how much can we trust it? How much does it really know if they're giving us weird results? Here's an example. It takes a human being about 14,000 brain hours to learn to run, right? Now an AI can figure out how to run in less than half as many CPU hours, but the results look like this. Yeah. Yeah. So using the arms for forward momentum, kind of not a lot of consideration of the physics of friction or maybe the realities of rotator cuffs. Um, but then again, we also come up with strange approaches to locomotion. Just consider the Prancer-sized craze of 2013. I don't know, you guys remember this one? This was shared a lot back in 2013. When people are so difficult to understand, so often unpredictable and eccentric, how can we expect the machines always to make sense of what's happening? So if the machines are weird, it's in part because we're weird, right? We may never totally understand what we look like to the machines from the other side. We communicate and behave in ways that are not always predictable or that themselves are fanciful. So, if we think about that, in that sense of sort of humans as fanciful, what do the machines make of us as creators or artists? This Renoir painting is in the collection of the Barnes Foundation in Philadelphia. And when curators ran it through a computer vision algorithm for identification, the robots confidently identified it as a boy holding a teddy bear. And you might guess they were using Microsoft's image recognition. It sees teddy bears everywhere, apparently. But they didn't strictly see this as a failure either. I mean, it was a failure in the sense that, oh, we shouldn't probably use this to auto-generate text descriptions, alt tags, for example, of our images on our website. But there are sort of other opportunities, right? So when they asked the neural network to find cherubs, the little angels in their collection, it found things that were definitely not cherubs, but also were sort of cherub-like. And so the curators began to find some interesting connections, some productive friction, connections between artworks in sort of a visual sense that they hadn't necessarily made before. Shelley Bernstein led this machine learning effort, and she described these connections as magic. That these sort of unexpected results had generated new insights, and in fact, some of the curators had written some papers that came out of it. So you may not always get what you expect from the machines, but sort of follow that thread. Consider this a productive friction. The patterns and connections that they make can surface themes that might otherwise remain invisible to us, the unexpected. So speaking of unexpected, let me use that as an awkward segue to talk about unexpected visitors. BJ May is a gentleman who has one of those creepy Nest doorbells with a security camera built in. And he did some customization with face recognition to lock the door if someone unknown approaches. So one day, though, it locked BJ himself. So he goes to investigate in the app, and it says that it's seen a new person. You want to let this person in. Do you know this guy? This guy? So the system had the good judgment to lock this man out of our house. Don't let that guy in. But obviously, totally misunderstood the context, right? The machines perceive and interpret the world very differently than we do. So weirdness and unpredictability and mistakes are essential to this design material. So the more that I work with machine-generated results and machine-generated content and machine-generated interactions, the more I realize I'm not in control of that experience as a designer. And that's kind of new. We're used to designing a fixed path through information and interactions that we control. We're used to designing for success, for the happy path. And now we have to anticipate a fuzzy range of results and confidence. And this is why it's so important to understand the texture, the strengths and weaknesses of your specific model, to understand its limitations and its constraints. So if you remember that brief that I showed you detailing opportunities for AI in a call center context, in these briefs, I always also encourage creating kind of a weirdness section. How are things going to go wrong with this approach? If machine learning is not as magical as we'd sometimes like it to be and too often imagine it to be, what are the ways and impacts that it could go wrong? Because anticipating those things help us design for them. So I think it was Amanda who asked earlier about sort of what can go wrong in healthcare. That's obviously a very high stakes thing where mistakes are costly in really serious ways. Really thinking through what happens if something goes wrong and where is a really important part of this. As we design in anticipation of that, this right here is always our challenge and our job, is how do we sort of set expectations and channel behavior in ways that match up to the system's ability. It becomes especially important for when you're working with sort of the fuzziness of machine learning. So how do you do that? Well, friends, the answer, of course, is BASAP, which we all know stands for be as smart as a puppy. This is a phrase from Matt Jones of the late great digital agency Berg London, now at Google. Berg London was sort of a pioneer in connected devices and their own kind of digital weirdness, really. But Matt came up with this way to think about creating honest and gentle interfaces for our strange systems. That the goal should be making smart things that don't try to be too smart and that make endearing failures in their attempts to learn and improve. So a lot of this is just sort of like, let's be honest about what this system is good at and what it's bad at, and even sort of embrace some of those issues almost as a form of personality, like puppies or robot football players.
So elusive, can it contain him?
Snapping ankles along the way.
Run again! This run is uncontainable!
All right. Obviously, you didn't have a lot of expectations of sort of that these were going to be fantastic football players, right? And it was clear from the manner. It was like completely sort of clear what your level of expectation might be. The right manner helps us to anticipate and forgive and recover from error. It may sometimes be annoying. Even puppies can be annoying, but it won't surprise us or endanger us, right? And I'm not suggesting that every robot interaction that we have, every machine learning interaction should be cute, but it should be clear what its abilities are so that we're not surprised when something does go wrong. Because again, that can be sort of dangerous. Too often when machines make a mistake, it feels more like this. Okay. No babies were hurt in the making of this video. That was a doll, just a doll, everybody. But that's the way things feel, right? That's about the design. How do we cushion mistakes? How do we signal that a mistake could happen? How do we set expectations? So one of those things, right, is that because the machines are weird, we need to match language and manner to the system ability, right? Alexa and Siri and Google Assistant, they all overpromise. They front as nearly human assistants, right? Their invitation is ask me anything. And as capable as they are, that's an expectation that they can't fulfill. So as amazing as those technologies and services are, they always disappoint because they are over-promising and setting the wrong level of expectation. They'd be better off being as smart as a puppy. I want to, in terms of sort of expectation and sort of what I'm talking about in terms of enabling that kind of trust with manner and language. This is PicDeskBot, which is a recently disabled, for reasons I'll talk about in a moment, Twitter bot that takes images, runs it through, in this case, Microsoft's image recognition service, and just puts the description that it gets back from it. And it can be quite good, right? You can see a herd of cattle grazing on a lush green field. It's almost poetic. It doesn't always get things right, though. It's kind of ridiculous confidence here is actually part of the charm. A dinosaur on top of a surfboard. We're able to understand its error, of course, because we can see the picture and fill in the gaps. But its kind of confidence of the answer is almost hilarious, right? But what if we wanted to try to make it more accurate, for people with visual disability, for example? When you submit the image to Microsoft's computer vision API, and this is why I encourage you to play with it to get a sense of the texture of it, you actually get back a good bit of information. And we start to see that its view of the image is more nuanced than that description suggests. So let's take a look. First of all, you can see here this confidence level that goes along with that description, a dinosaur on top of a surfboard. 0.257 confidence. That means that it's actually only 26% confident that it's a dinosaur on a surfboard. But it's 97% confident that it's a dinosaur. So it's actually, the algorithm is being really honest about its uncertainty here, and that it's maybe a little more clever than we knew. How might we adapt our design to better reflect our actual confidence? Tweaking language certainly can help. So instead of a dinosaur on a surfboard, perhaps we say a dinosaur maybe on a surfboard, and we show the actual confidence level. We're getting there. We could also reveal maybe more of that nuance, showing that we're really confident about dinosaur, but not so much on surfboard. You get the idea, just sort of riffing here. But when the algorithm is a little confused, let it say so. So another miss from PickDeskBot. You might recognize the new Samsung model here. They really just do get bigger and more full featured every day, don't they? What we're sort of seeing here is, it's saying a person holding a cell phone. What would probably be more accurate, but certainly vaguer, is a person holding an object, right? But we could sort of start to say, based on the data, it's like maybe it's a cell phone or a guitar or a violin, some things that we can sort of find some of the other things that it's suggesting and sort of present them according to the confidence level for each. I'll talk about understanding and managing confidence a bit more later. But here's the takeaway. Correctness is more important than specificity. So better to give a vague answer that's correct than an overly specific incorrect one, right? This was a study, this is from a study that was done of people with visual disability that found that people who did not have very clear vision understandably put a lot of trust in machine-generated captions because that's what they have to go on. And instead of discounting them as incorrect, they fill in details to try to resolve a conflict. So effectively add more to the image in their minds. So the study sort of found that while these users felt that, believed that they were skilled at detecting bad captions, the study didn't show it. And so the study concluded that rather than promoting trust and sort of saying, trust me, I'm super right about everything, the best approach is to promote skepticism, to engage the critical mind, to be forthright about confidence. I think all of these things sort of touch obviously on what Margot was talking about in her session on trust, around voice and around how to build kind of earned confidence. And this is a big part of it, is to be transparent about what the system is good at and what it's not. Some kind of object, maybe it's a cell phone. That manner and transparency is important. And that's in line with what we started this workshop by saying, is let's amplify judgment, let's engage critical thinking. The machines can be enablers of creative and critical thought. So part of promoting trust is actually promoting healthy and appropriate skepticism, engaging the critical mind. The second aspect that I want to talk about here is the really narrow domains that any given machine learning system can handle. So CycleGAN is a tool, a neural network. It's trained on pictures of horses or fruit and taught to transform them. So a picture of apples becomes a picture of oranges, or here you go, your horse is a zebra. There are some bugs here, right? It gets confused when you run pictures through it that don't fit its model, right? So here, Vladimir Putin is a zebra too. If it only knows horses, everything is a horse, right? Or everything is a zebra. Look at the rocks in the background of this image, right? They've sort of turned into zebras as well. So it's just a reminder that machine learning and AI is not real intelligence. At the moment, this is pattern matching on a highly specific domain, not intelligence, not expertise. There is no logical inference. There is no deduction. There is simply matching at a vast but ultimately childlike level, which is one of the reasons I love this comment from Benedict Evans, is it gives you infinite interns or maybe infinite 10-year-olds. It doesn't give you one super mind. It gives you sort of the effectively sort of like a whole bunch of 10-year-old interns maybe. So 5 years ago, if you gave a computer a pile of photos, it couldn't do much more than maybe sort them by size. Perhaps a 10-year-old could sort of start to sort them into men and women or categorized by age or something like that. A 15-year-old maybe into cool or uncool if you're lucky. And if you have an intern, you could sort of say, this one's really interesting. And today machine learning is sort of at that 10 or 15-year-old level and sometimes does approach that intern level if the domain is really specific enough. So what would you do if you had 1 million 15-year-olds look at your data? Is sort of one way to think about the results that you can get out of that. What might they find in particularly a narrow domain? So think about solving narrow problems. And this goes on also sort of those really almost mundane solutions that we were looking at as examples in the beginning. Is how can we sort of like help in this really one specific context or critical task? These narrow problems don't have to be small problems. You know, we have analysis of climate change or the evolution of epidemics, uh, of general healthcare. Deep Patient is a system that analyzes hundreds of thousands of medical records looking for patterns. It anticipates the onset of schizophrenia surprisingly well, and it turns out human physicians are not very good at that. So looking at a narrow slice of patients, it can address this big problem of diagnosis and then focus doctors' attention and judgment on that area. So this is a little bit like what we were talking about with the x-rays, but doesn't have quite as much of that critical false negative problem here. In fact, it's sort of saying maybe 2 years before something would come to a human physician's attention, the system can kind of say, hey, have a look at this person in this context because there might be something here. Now, the unnerving thing about this is you'd hope the system would have clues about how it does its work, right? Could provide some indications, could give us some knowledge about the causes or indications of schizophrenia. But it can't give a rationale for its prediction. It just sees a pattern and reports it. You know, it's like ka-chunk, 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 ding, schizophrenia. It just sees the problem and reports it. Even the project leader doesn't know how it works. And this is a little bit unsettling with big problems or personal problems like healthcare. We don't understand where information came from. Can we really call it knowledge? So it can address big questions, even within a narrow domain, but it does sort of create this other question or issue that I want to talk about as sort of this third aspect of the texture of machine learning is that the logic is opaque. Here's a ridiculous example about me. I don't know how many of you use the Discover playlist in Spotify. Whenever I listen to it, friends, I feel like we're close enough that I can share this with you now. My playlist sounds like this. My Discover playlist is deeply uncool. And the thing is, it's right. I am deeply uncool. I wish I was cooler. I'm embarrassed. I don't know about you. Sometimes I guess I don't like the reflection I see in Spotify's musical mirror. So I find myself trying to skip the music that I'm afraid Spotify will judge me for. But also I'm afraid to skip. Will I never hear that song again that I deep down secretly love? So I sort of want to impress the Discover playlist, but I also don't want to lose the songs that I like. So my mental model of how it works changes how I behave, but I'm also not sure if my mental model is correct. So I wind up paralyzed, right? So this is true for any application, but it's especially challenging with these systems. Part of our obligation together is to create data literacy, how to help people understand how the internet works, in a sense, as well as our specific services. How does the system behave? What signals does it observe? What is it optimized for? So back to Spotify, the interface should give explicit feedback to indicate how fast forwarding a song affects your profile, if at all, right? So it's the kind of thing of like, great, you're skipping it, but by sort of suggesting that you can remove the song from your history, you're also sort of saying that it hasn't been removed, right? So it's something that's giving some sort of sense, suggesting how the system works. This could also turn into a really fun opportunity, or in my case, a deeply embarrassing one, to sort of explore your own taste, sort of help to show how the Discover playlist is associated to songs that you've listened to recently. All right. So signal your intention. When are you capturing information and to what end? Be transparent. Signal when you're capturing information and show when the actions are having some effect on the underlying model or what you're doing. This is kind of a problem because transparency is not a core value of our industry. You look at the big platforms and they are hardly transparent about when they're taking our information and what they're doing with it. And you might say, well, you know, if we say what we're doing, people might not sign up. They might be turned off. And I guess to that, I would say, if you think people won't like what you're doing, you probably shouldn't be doing it, which kind of goes to that question that we heard earlier about the B2B services, about sort of like, are they going to be comfortable with using our data? Well, you should ask them first and be really transparent about what's happening. And perhaps they'll see the value in it and perhaps they won't. But the idea here is that we need to make transparency a default design principle. And what that means is the system should declare what it is optimized to do. And this is something you should do not only for users, but to be crystal clear with it in your own team. What are the results that the system wants? What does it consider to be normal? And because its logic is opaque, you need to check that the optimization is working. And so this comes back to a question we heard earlier. How do you think about measuring the results? Is the system delivering on what it's optimized for? And is it possibly undermining other things that we care about but aren't explicitly optimizing for? Now, we can't necessarily understand its logic, but we can understand the results. If we're optimizing for this thing, is it working? Fix the systems when they don't hit their marks and celebrate and improve them when they do. So we might not always or ever understand how the systems think, but we can understand and compare their results. And so you should do that. One thing I want to mention too is that machine learning is probabilistic. Machine learning sees the world in shades of gray. Nothing is fixed. It's all probabilities. Its algorithms are really explicit about their confidence in their predictions. We saw this a bit in our dinosaur example. Let's look at a few other examples and then dig into the implications and our responsibilities as designers. You know, I am just self-involved enough to go ahead and just run a picture of me through Microsoft's image recognition system. And behind the scenes, as we saw earlier, it returns this structured data. So let's climb in and take a look here. First, it's saying, you know, this is a man looking at a camera with an 89% confidence. It's not too bad. I'm not totally sure about some of the tags that it's putting on here. And hey, come on now. Seriously, really? This is the kind of thing that's going to stick with you, friends. I got to tell you, it's like not necessarily a great feeling. But actually, then if we don't necessarily agree with all of the results, let's look at the percentage to get a sense of the confidence that it has here for things. One thing to know is that the tags sort of are shown in descending order of sort of what it believes is sort of most important. And so it's sort of identifying this first as person, man, indoor, and it's only really when you get down later that it's not really sure that it is older. In fact, down below at the tags, you can see only 28% confidence that it's older. So, you know, I'll take it where I can get it. We see, you know, a lot of times that that systems will actually surface that confidence level. So we see this in Netflix and its recommendation engine. And we saw it when we dug into Microsoft's image recognition API, right? So Netflix surfaces that confidence number directly. In usability testing, though, I see that confidence numbers like this are often not well absorbed or understood. They don't hold much meaning. They're kind of glossed over. So there was no lack of confidence revealed at all to our friends in Colorado, right? And no caveats to the recommendation. All they heard was save 20 minutes. But what if Google Maps had also shared some of the new route's unusual characteristics? You know, that maybe it's a gravel road, it's a private road, it's a rarely used road. How can we sort of give some caveats to the recommendation, acknowledging the possibility of alternate outcomes? I think I know, in other words. The manner with which we present information is astoundingly important. And the way we think about these signals is important too, because they're always signals that are relative to a baseline. So we want to sort of acknowledge that the model, to ourselves, that the model can be wrong, and frankly, even surface that to our users. What are the downsides of this recommendation? So the kind of caveats that Google Maps might have suggested are not all that different from the caveats that we're sort of looking at here in that example we were looking at earlier. We're revealing the uncertainties or downsides of the advice, the recommendation, or the prediction. So in applications like this, the stakes are pretty low, but there are other places where the stakes could be much higher. Frankly, even with something as seemingly frivolous as our friend PickDeskBot. So this past summer, as PickDeskBot automatically rattled away and posted a photo of a dental hygienist with a patient who was a Black man. And PickDeskBot identified the photo as a person with a dog. This was 10 days after George Floyd's murder in Minneapolis. We're starting to talk about real harm in the language of AI. So the creator of PickDeskBot here acknowledges that AI can be racist, and I'll talk about that in a moment. And that was the last post of PickDeskBot. The creator pulled it out of commission because he judged that the potential harm, even a single post after hundreds or thousands of benign posts, that harm outweighed the benefit of its entertainment or education value. Of course, the stakes get higher in cases like law enforcement. We're starting to see police, of course, using face recognition algorithms or pattern matching for predictive policing. Nor are the machines up for it. The ACLU ran photos of Congress against a data set of 25,000 mugshots and got 28 matches of US congressional representatives. So Amazon has apparently confirmed with science that Congress is a bunch of crooks. So if we looked under the hood here, though, what we see is that ACLU left the setting to the default, which declares a match when there's 80% or better confidence. And Amazon countered and said, hey, hang on a second, we tell police departments to use at least a 95% confidence. This is a probabilistic tool. But in a way, that makes the ACLU's point. The machines require careful tending. Those of us close to the machines need to understand how confident and accurate they are, of course. But we also need to make that transparent to the users, the civilians who get this results from us, because it can have, real impact. I don't know is better than a wrong answer, especially a hurtful or hateful or awful answer. So I think I know, though, can be pretty good. Maybe you're an older man. Maybe you're an elephant. How do you suggest it instead of just saying, this is an older elephant? So introducing a productive humility here. The idea is that the algorithms themselves are pretty clear about their confidence. They often honestly report that they're guessing, but our interfaces don't reflect that. And that's a design problem, a problem of presentation. So the responsible presentation of algorithmic results is as important as the underlying algorithm itself. Friends, I know that we're about a minute over here, and I'm going to wrap this up in about 5 minutes for those of you who can stick with me. That's what's ahead. But the goal here is that we really want to present information as signals, not as absolutes. And that's a big part of sort of what we were talking about in terms of not replacing human judgment, but focusing it and bringing attention to it. That's important too, because there are sort of notions of these things are all pegged to normal. As we're sort of starting to think about giving things a signal, it's important to remember that it's based on this sort of baseline. And that's really the whole point of these systems, is to identify what normal is and to predict the next normal thing, or to call out things that are different from normal in some interesting way. But of course, if normal isn't necessarily, what is the definition of normal? If you put this image of David Bowie through face recognition, what you get back is that this is a 29-year-old female. And of course, we're going through this sort of, I would say, global and cultural conversation about what gender is and the meaning of it and its fluidity. And so the idea is that if the systems are trained on a certain notion of normal, and that isn't everyone's notion of normal, or normal changes, then that whole sort of notion of garbage in, garbage out becomes really important. What if the prevailing notion of normal is actually garbage? What if our machines learn from us or our own bad or dubious choices? What if they absorb and reinforce existing inequalities or leave out entire categories of people? We saw this happen about 18 months ago with Amazon when they were using an AI tool to sort of help do some triage of resumes, and found that it had a bias against women. And to their credit, they immediately pulled the system. But basically, the system was looking at sort of the data and was sort of, because there was sort of a prevalence of men applying and perhaps being hired or promoted, its conclusion was that women were less suited to the job. What this is doing is essentially using the existing data to codify the past. This is a phrase from the data scientist Cathy O'Neill in her excellent book, Weapons of Math Destruction. On the surface, you'd think that removing humans from a situation might eliminate racism or stereotypes or any very human bias. But in fact, the risk is that we're baking our bias, our past history, into the very operating system itself. So in the cases of predictive policing or sentencing algorithms, where the data is so completely biased against Black men, or hiring and promotion algorithms, where the historical data is biased against women and people of color, the data bias codifies that ugly past. But surfacing that bias might just be useful, right? And I don't want to put too much of a gloss on this, because this obviously can be very damaging. But the machines surface this bias naively, in a matter-of-fact way, without trying to hide anything. They make obvious what's always lurked beneath. And this reveals the problems that we have to solve or address, perhaps in our mathematical models, or maybe more often in ways that our culture operates, or the limitations of our own narrow professional circles in the case of Amazon. And so when bias is revealed, we can act on it. And I'm not just talking about the bias that we're talking about here of sort of gender, or racial, or demographic bias, but any kind of bias, anything that sort of is overfit to some notion of normal that may not represent all the cases that we want to get. So when we're looking at measure, 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 we have to sort of be constantly looking for these elements that introduce some sort of bias toward a normal that may not be the normal that we actually want to have. We may not be able to eliminate bias from our data, but we can certainly surface it as a call to action. So there's a lot to be sort of said about machine learning and its sort of special aspects and things that we need to be cautious of as well as embrace. And this is, I think how we want to look at working with it. I think broadly, if you sort of look at what we've been talking about here over the last 90 minutes, though, this is sort of like the core takeaways of how to think about where machine learning fits, and encourage you to play with some of those services that we were looking at as part of your homework that'll be in the slides that we'll share in a moment, to sort of think about exactly what are these elements where it would fit. But then as you're also doing it, I just encourage you also to think about what are the intentions that we want to bring to this technology? How willing are we to consider that things are going to go wrong and that the technology is going to have unintended consequences? And how do we design for it? What do we want from the algorithm? But also, what is it going to require of us in return? Beyond the interaction, what is the larger outcome that we want to see? And what trades are we willing to make and to be transparent about our customers about those trades? Because if we don't decide for ourselves, the technology is going to decide for us. And friends, the thing I would say is that the future should not be self-driving, right? Let's be intentional about what we're going to do here. So one last example, and then I'll let you all go. What if when you're sick, the machines handle the diagnosis? They look at your symptoms and tests and sort of determine what's wrong and suggest possible courses of action. Now, if the experience ended there, that would be abject, right? That'd be sterile and soulless. But what if then the doctor came in and their job is not to do the analysis, the machines have already done it, but to deliver the message in a way that is caring and warm? The doctor would let the patients tell their stories. So instead of 5 minutes with the doctor, the patients would get the time to feel heard and ask questions and be reassured. And perhaps that caregiver doesn't need as much education as sort of in the current system, which makes for less expensive healthcare, and which means maybe we can have more caregivers for more jobs. So better care and lower health costs and more jobs. That's a good outcome to design for, right? But the intention matters. That's different than designing simply for efficiency. So all to say, as we think about how to use this, instead of humans working for the machines can, as I've said, amplify our potential by doing our joyless work for us and delivering new insight from it. So instead of hijacking our agency, they can augment our judgment so that we can be, more creative and more insightful and more compassionate. We're kind of in this together, right? But it also means that we're inventing the future together, all of us here in this session, as consumers to some degree, but especially as designers. And machine learning gives us powerful tools for meaningful change and human insight. And as we've seen, if mishandled, things can go wrong in ways that are sometimes simply funny, but also really damaging. But I'm optimistic. I choose to be excited. This new design material is ready to use today. Put those tools that we surveyed already here to work in small interventions or even in some audacious projects. You have the chance today, I would say, to make something amazing. So please, friends, go do that. Make something amazing. Thanks so much. I really appreciate your time here today and for joining me. Apologies to go a little bit long. Thanks for sticking with me. Friends, I know we didn't get to answer quite all the questions. I'm happy to continue this conversation on Slack and I hope to see you soon. Thanks so much.